Having thought about it a little bit, I decided I'm gonna make the next homework on chapters 5, 6, and 7. I mean, 7 is pretty much an integral part of 6. So I'll post the assignment on Thursday. So you'll have until next Friday to do it. It'll also be a good practice for the exam because it's going to cover a lot of uh, calculations. This chapter is about once we get our numbers, all the project cash flows, we calculate our MPVs, other criteria, then we're going to think about, well, I got this number, MPV, $5 million negative. If you remember from our last time, based on the parameters we had, on that example, we had a negative $5 million, no, positive $5 million in NPV. It's not too high, but it's not too bad either. I mean, it's in the yellow zone, especially if it's in the yellow zone like that. The first thing I'm going to think about is that number 5 million is based on the inputs that I have, which are themselves estimates. You know, things like cost of machinery and stuff like that. That's somewhat technical stuff, so I don't view that much risk on those. But things like how much I'll be able to sell the first year, the growth rate of sales, how much I'll lose my existing sales, these are all forecasts, which means, there's a probability distribution about them. So we kind of need to think about two things. One, how sensitive these results are to those forecasting risk. And two, uh, if I can come up with some reasonable scenarios on best case, worst case, what sort of MPVs should I expect? Basically, there are two types of analyses. One is called sensitivity analysis. The idea behind sensitivity analysis is simple. Assume that values of inputs, except for one of them, are the same as the base case, and increase or change by a standard amount and calculate the change in MPV or IRR or something like that, whatever your proper measure is. So let's go ahead and do that. That's my MPV. I'm going to put in the base case MPV here. I'm going to simply copy and paste the value. Maybe make that red. And I'm going to measure sensitivity as MPV minus the base case. Let's make this a different color. Maybe something like that. Okay. Obviously, as of now, it's zero. Now let's think about one of our inputs. Since most of the forecasting is based on the sales on cost, let's increase first year sales of the new product by $1. Okay. Since we set up our spreadsheet so that as soon as I change that input, everything else is calculated. All I have to do is go here and look at it. Turns out, given our base case scenario, every $1 increase uh, increases the MPV by $2.62. Alternatively, yeah, think about that. Instead of $90 million first year sales, what if I had 88? And based on that, that's going to give me something above a decline of MPV that is above $5.2 million, which is going to end up making my MPV negative, right? So let me go back there and change that, even though I know what's going to happen. Sometimes it's a good idea to see it for yourself. Now, what do you know? It's actually negative. So there is forecasting risk. Or let's make it even a bigger change, maybe 85. I mean, it's basically slightly over 5% change, right? Or let's do 10% from the base. Yeah, I even get a red down arrow. So there is forecasting risk. Obviously, when you do this analysis, you're going to attach a probable distribution to your forecast. If this was a master's level class and you had to have had taken statistics, I would have said calculate something like root mean square error of forecast, blah, 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 and go from there. But the risk is there. One issue with uh, sensitivity analysis is you do this one variable at a time, okay? Uh, or as we call it in economics, this is a ceteris paribus or ceteris paribus analysis. Well, as my econometrics teacher used to say, in real life, ceteris is rarely paribus. Ceteris paribus means everything else being the same. Okay? Obviously, in life, you can't simply control one thing and everything and change only one thing. You can do those in, controlled lab experiments. Even there, I'm not sure you could, but at least it'll be close enough. Economics is, never a controlled experiment. Rarely you can have some natural experiments, but in most cases you don't. I'll give you an example of an accidental natural experiment. Um, as you're going to see when you take the exam, I have a specialized software that delivers the exam, and you have to download some sort of HTML content to your computer and run it that way. I used to do it from Blackboard. And last year, fall, I did the first exam, no problems. Then we came to the second exam, and it was my Monday, Wednesday, 9:05 class, and students uh, started the exam from Blackboard. About three questions into it, every single one of them got a fatal error. It's the same software. I just changed the questions, same blackboard, same way of delivery. Anyway, I ended up telling these students, okay, you guys are going to take the exam at home. I didn't want to, but since I told that section, other sections had to have it too. So this was a natural experiment, even though I didn't intended it, to see what was the effect of taking it at home versus in class. Same time limits, no problem there. And turned out grades were much higher. That I expected anyway. What I had not expected was the lack of correlation between the results of the first exam and the second exam. I had one student who had a 32 from the first exam, which is difficult because the way I construct my exam, if you randomly pick everything, you should be able to get a 42 on average. Anyway, and the same student got a 98 and a half in the second exam. Either he basically said, okay, if I don't change my act, something else is going to happen to me. I doubt it because once we came to the final, I fixed the problem. He went back to 40s. The correlation between the results, I even did a rank correlation. You rank the grades in each exam, you see how the ranks are correlated. It was 8%.